So please, Seif. And I will keep track of the time now.
I have only 10 minutes.
Yeah, I have only 10 minutes.
So I'm going to talk.
Up after 8.
So I'm going to talk 10 minutes just as an introduction of some of the activities at SICS in the area of big data research at SICS. So it's very short, and it just give you introduction to what you're going to see. A lot of these things are here in this document, and if you go to SICS, then later to the demo, you will see all of these organizations. Okay. So let me just quickly talk about what's happening now at SICS in the big data area. So research at big data area. So basically, more and more data are available to science and businesses. Okay. So, and this has been now available that we can do amazing things. So, and of course, the drivers of these things are cloud computing. Why cloud computing? Because it leads you can store and have the ability to process large data. You have the Internet of Services, the Internet of Things, the cyber physical systems, and underlying trends like connectivity, collaboration, and computer-generated data. So what is the promise? The promise is that data-driven application, I would say data-driven society, will revolutionize decision-making in business and in sciences. And of course, in many areas, as you can see here, from life science management, home application, health, e-science, and so on. So this has a great potential. But in my view, it is just a potential. It's not realized. And why is that? Because a prerequisite, a technical prerequisite actually to be able to realize this potential is how can you handle data and scale and how you can do deep analytics. If you see the current picture of what's going on today, we have system for small data, like Excel, which do simple analytics, or system that does a little bit more deeper analytics, like MATLAB and R. And on the other hand, we have here system for big data, but actually don't do deep analytics, okay? So, and this gives us what is a research focus of what we can do at SICS. Huh? We want to do something for the future, so the research focus is to scalable system and algorithm for deep analytics on big data. This is what we want to do. And here is also the emerging platform. This area is actually is flourishing now. This is an emerging platform where you have a lot of products now, both commercial products, open software products, from simple analytic products to deep analytics product. And you can see that this square is still empty. The square where you can really do deep analytics and big data. In fact, so the world is moving into this direction, the direction this way. So this is where opportunity for research can be done, okay? And so what I'm going to give you here is some examples of the research we're doing at SICS now, and we are planning to do to move into this area. So just to give you very quickly some things that we are doing. So there are two things that we can say we are doing. One is the platforms, the systems that are used to move us into this area, and the other is the algorithms. The algorithm is a very important part because the algorithm that can handle big data and also be able to do deep analytics, abstract conceptualization, and things like that. Okay, so there are two systems that we have been working on, which actually trying to improve them related to this picture. One is a system called Apache Flink, which is Apache Flink is a big data analytics system that has been developed at Europe. And the other thing we have been working on improving is the Hadoop system. So here's some examples of projects. You will see at up. So the Hadoop system. So we have a project called HOPS, and I think Jim is here somewhere. No? Okay. So you will see this up, and we have been working on trying to scale the Hadoop file system and the Hadoop scheduler. Okay? The other thing we have been doing is a part of the Flink Big Analytic Apache project to do real-time streaming. Real-time streaming, so it's real-time analytics streaming in an open source project. So we have been contributing to this. If you look today to how people see this kind of system, now there's an emerging what is called big data analytics stack. The big data analytics stack comprises of, first you have the storage system at the bottom. The storage system, these are systems that are actually working on commodity clusters on data centers. Then you have the resource manager, which is like the operating system of the big data. And then you have a number of emerging technologies like Spark, Flink, and the old MapReduce technology. Okay, this is an old one. On top of that, you have a number of high-level frameworks. These are platforms that will allow you to do better and deeper analytics. Okay? And we have been working on scaling up the Hadoop file system, on scaling and improving the resource scheduler, working on improving Flink, especially in real-time streaming, and now we're starting work on doing more and more libraries for big data for machine learning in the machine learning area. Okay. Just very quickly to show you some of the projects, and you're going to see this up. So we are actually now going to announce a new implementation of the Hadoop file system, the HDFS, which is more scalable. It's 10 times more scalable than the current Apache Hadoop file system. It supports terabytes of metadata. It's easy to customize the data, and it's basically based on using in-memory, in-memory database to manage and coordinate the data nodes of the system. The other project, and you can hear more about it later, the other thing we have been doing is also improving the scheduler in the Hadoop file system, the Yarn scheduler, to be able to scale it and to distribute all resources, so it's more a distributed scheduler. And that will actually scale the scheduling to allow larger and larger number of tasks on these type of systems. Quickly again, so now an important trend in analytics is streaming analytics, where data just comes in. And you want to do analytics on the fly in real time. The current system existing today are typically Apache Storm. That is a system that is used, for example, by Facebook, which is true streaming, low latency, low throughput, but very low API. It's very hard to program, to put components together. Okay? The other system that is now emerging, a system from Databricks, it's a company in the US, that supports Spark. Spark is like now the new kid in the block for big data analytics in the US. So it's Spark streaming. It's take batches of data and do some like full type of analytics on these batches of data. So, and there is also now what we have developed, which is called, we are developing still Flink streaming, you can see upstairs, which is true streaming engine with very good throughput. But the most important, it has a rich functional API and support different APIs, different languages like Scala and Java and so on, and you can write things in a very simple way with stateful operators that really very important for doing real-time analytics in a deep way. So just a picture, the performance of currently of Flink streaming is really outperforming systems like Storm. So please just go and have it and look about. The other thing that we are doing is research in algorithm and analytics themselves. Okay. Specifically, we're doing research on clustering and anomaly detection on streaming data. We're doing work on clustering and in large graphs, it's graph analytics. We're doing work on large-scale unsupervised and deep learning. Deep learning now is an emerging area in machine learning, which you can really learn concepts. with no supervision once you give it more and more data. We're doing research in distributed machine learning, where you can actually have the learning system distributed across many places distributed, and you can incrementally create the model, the machine learning from the data that you get in. Just very quickly, we have been doing work applying these techniques in text mining and analysis, in syndromic surveillance, in diagnostics, in anomaly detections, in mobility patterns, and traffic modeling, and in network analytics. I don't have so much time because of the time, so I will just show you the slides. So we do this community detection on large graphs. We can analyze, basically based on mobile cell movement within a mobile network, and detect a lot of information like the trajectories of where people are going, if they are even riding a car or in a train, and so on. And we do this with data analytics. And this can be applied in many applications like urban planning, crisis management, traffic management, and so on. We have been doing traffic modeling for in-network analytics for Ericsson network, basically, which basically we can take in huge amount of data and do real-time traffic modeling of the streaming data. This real-time traffic modeling will allow Ericsson to use these models to predict what's going to happen if they are going to run some other services or applications. So, okay, so now to end up, we started a project called Large-Scale Machine Learning, which combines statistical machine learning techniques on massive data, incremental scalable machine learning models, and platform for storing and processing very large data. This is just a project that started, and we want to focus more and more in big data, deep analytics. Okay, just to finish this with one more slide, which is, so people talk about digitalization of society. I'm talking about the data-driven society, We just touched on one point, which is the technology dimension. There are many other dimensions. Maybe we mentioned some potential applications. There's still other aspects that have to be developed to realize the potential of a data-driven society, like the legal dimension, the social dimension, and the economic dimension. Thank you very much. That's my time.